Okay, so let's continue finding the solutions or the roots of polynomials. Now, what we did before, right, we were factoring, and we used the fact that if you have the multiplication of two things equal to 0, at least one of them must be 0. So what happens if you can't write this equation out as a factor, right? That is possible. So what we're going to do is we're going to use the quadratic formula. Now, be very careful. This only works on quadratic equations, so things of the form ax squared plus bx plus c equals 0, which means, again, you have to bring everything over to one side, set the right-hand side equal to 0. And what it does is it tells you the x values, which are going to be given by this equation, which many of you have probably seen before, is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, just a little bit of tidbit of information. The square and the cubic actually have general formulas like this. But anything above a third-degree polynomial, you can't find a solution, not a general equation where you can plug in with this. So if you want it to be easy, you want to use things like a second-degree polynomial and then a third-degree polynomial, which can be quite difficult, but at least has an equation to solve for the roots. So let's go ahead and use that. Okay? And what we're going to do is we're going to bring everything over to the left and first check to see if it's factorable, because that should be the first thing that you try always. So subtract 4 out to the other side, so both sides. So what we get here is negative w squared plus 4w minus 4 is 0. So hopefully everyone can see here that the 4's, if you take out the minus, let's go ahead and do that. If I have the 4 over here, you have 4 and 1, and then 2 and 2. So if you do this and you see that it's factorable, what you can do, right, is write it as negative w minus 2 is 0. So w is equal to 2, and w is equal to 2 here. So the multiplicity of the root of 2 is going to be 2. But we want, just using this as an example, this is going to be much easier to solve through factoring. But let's just go ahead and do it with the quadratic formula to see what happens. So let's look at the top. Here, this part over the first part, this is a. So a equals negative 1. The next one, b is equal to 4. And then lastly, c is equal to negative 4. So take those numbers and plug it into this equation. Now, be careful, okay, when you're writing this out, this represents the input value, not just x. So the input value here is going to be w, so make sure you write that. W is equal to negative b, which is 4, plus or minus the square root of b squared minus 4 times a times c divided by 2a. And then go ahead and just do the arithmetic. Negative 4 plus or minus the square root of 16. This one right here is going to be negative times a negative, which is positive, times a negative, which is going to be negative again, 16 over negative 2. This is 0. So you get negative 4 plus or minus 0 over negative 2, which is 2 plus or minus 0. So again, we have the roots 2 plus or minus 0, so it happens twice. So you have a multiplicity of 2 with a root of 2. Now notice again, it says that the input w is 2 will make this equation true, or if we plug it into here, we'll give you an output of 0. Now, let's go ahead and do this last example. And this example is not factorable. And we'll see why when we actually plug it into the quadratic formula. So let's go ahead and write this. This first part here, a is equal to 2. The next part, b is equal to 3. And then, of course, lastly, c is equal to 5. So the input x is equal to b, negative b, plus or minus the square root of b squared minus 4ac divided by 2a. Now some of you may be wondering why I put all these parentheses. Remember, when you plug in for something, you want to replace it with parentheses and then write whatever you need to inside of the parentheses. And the reason for that is one of the common errors is when you do this square part, a lot of people will write something like that, and they'll only take the 2 squared, even though it should have been like that. Okay? So be very careful. That is why we write those parentheses and why we did it in the very first place, okay, is to get rid of those errors. So go ahead and do the arithmetic. 9 minus 10 times 4 is going to be 40 divided by 4. So negative 3 plus or minus the square root of negative 31 over 4. So remember, when we have that negative 1 on the inside of the square root, that gives us an I value. So we can rewrite this as negative 3 plus or minus I square root of 31 all divided by 4. And similarly, it still says the same thing. Remember, we showed this when we first did the I values, right? If you plug it in, it gives you a true statement or a solution. So if I plug this horrendous looking number back into this equation, you should get 0 out.